Alright, so in this tutorial we're going to be talking about variables. Now variables in computer programming are a lot similar to variables in mathematics. So if you have a good understanding of how to use variables in mathematics, then you have a good head start about how to use variables in computer programming. Now before we get into talking about variables, it's important that you get a good understanding of the 8 primitive data types used in Java. So we'll go ahead and get started by learning about those. Alright, here we have primitive data types. First, we have the byte. A byte is an 8-bit signed integer. Signed meaning it could be negative or positive. You can store a minimum value of 128 and a maximum value of 127 inside of a byte variable. We also have a short, which is a 16-bit signed. You can see the minimum and maximum value here. Same with the int and a long variable data types. Notice that the int and the long can be very small and very large numbers. Next, we have float and double. Float and double are decimal point numbers or real numbers. You could see that a float could be about 6 to 7 decimal points long. The double could be about 15 to 16 decimal points long. Next we have a boolean. In Java booleans, you can only store the values true or false, or expect to return a value of true or false inside of a boolean variable. And next we have char. Simply put, char, you could store pretty much any single bit character. 0 through 9, A through Z, uppercase or lowercase, special characters, things of that nature. Those would be the primitive data types of the Java programming language. In order to create a variable, you write a statement starting with the variable type. Here we're going to put int, then you put a space, and then comes the name of whatever you're going to call the variable. It is important to keep in mind that a variable name cannot start with a digit. It must start with a letter, a $, or an underscore. Variables are case sensitive, so whatever you call it here is exactly what you'll have to refer to it in the rest of your program. Do not include any white space in your variable. This will create issues within your program. Also, there are some reserved words in Java that you cannot name your variable. If you try to name your variable this, most likely Eclipse is going to throw an error and it will alert you of this. I'll go ahead and provide a link of the reserved names in Java. These will be the names that you are not allowed to name your variables. A common convention used in the programming language is camel casing. That means if your variable contains more than one word, the first word is going to be starting off with a lowercase letter, and every word after that will start off with an uppercase letter. Okay, so here we have our variable called firstInt, and we're going to go ahead and initialize it to a value of 10. We'll end that statement off with a semicolon. Then we're going to go ahead and do a system.out.println. And notice inside of these parentheses, what we do is we put the variable name, which is firstInt. If we run that, as you can see, what we get is 10. We go ahead and change the value of firstInt to 11. And if we run this, as you can see, we get 11. And as you can guess, if we try 14, we run the program, what you get is 14. That would be the most basic function of a variable. Now you can see if we try to put 14.032, puts a little red squiggly line underneath that number. If we hover over it, it's going to tell us type mismatch, cannot convert from double to int. It's going to give us a little hint of why that little red squiggly line is there and why that program will not run if we try to run it. So we'll go ahead and delete that. And underneath here, we're going to go ahead and put int, another int. Notice the camel casing that we're using here. We're going to put that inside of the println statement. And if we hover over this, as you could see, a little red squiggly line again, it's going to say the local variable, another int, may not have been initialized. It's because we didn't give it a value at the top here. But you know what, let's go ahead and try and run this and see what happens. If we click OK, click proceed, it's going to tell us the local variable, another int, may not have been initialized. So what we'll do is we'll go ahead and initialize that variable. If we hover over it and we go ahead and click initialize variable, what we'll do is we'll put in a equals 0 in there for us. So if we try to run this, it's going to give us that 0 that it threw in there for us. So that's something to keep in mind. If your variables aren't initialized and you try to use it, the program is not going to run. Let's go ahead and get rid of that second statement there. We'll go ahead and put firstInt back in there. And what we'll do is we'll divide that by 2. Now you can put any of the basic arithmetic operators in here. You put plus, minus, multiplication, division, and you can even put what's called a modulus operator. But for now, let's go ahead and just leave that with a division operator. If we run that program, as you can see, what happens is that expression is evaluated, takes that variable, the 14 stored inside of that variable, and it divides it by 2, what we get is 7. Next, what we'll do is divide this by 3. 3 obviously does not divide evenly into 14, so we should get a decimal number, right? But if we run this, what we get is 4. And that's because our variable first int is an integer variable. So what it did is it actually rounds that number down and it just gives us 4. If we want to see the values after that decimal, what we need to do is change this variable type to float. So we'll go ahead and do that, run this program here, and as you can see, now we can see those values after the decimal point. If we change this variable type to double, run this program again, as you can see, we get more values after the decimal point. So that pretty much lays out the difference between a float and a double for you. Let's go ahead and get rid of that. What we'll do is make a Boolean variable. We'll call this variable check, and we'll set it equal to true. If we print out this variable here, once again, we'll put the variable name inside of the parentheses. We get the value true. Now notice if we go ahead and put an exclamation point in front of the check, this actually is called a not operator. This will go ahead and give us the opposite of whatever the value is stored in check. So since check has a value of true, notice what this gives us. It will give us false, the opposite of true. All right, now let's go ahead and get rid of that. Next, we're going to go ahead and create a char variable. We're going to call this variable first char, and we're going to give it a value of a. Now, if you're declaring a variable of the type char, the value you give that variable has to be put in single quotes. Now, if we go ahead and print line that variable out, as you can see, we get a. Notice we could put 1 in here. Notice we could put any single digit number in here. Any double digit numbers give us an error. We could also use symbols. Now let's explore something here. If we create an int variable, call it char value, and we set it equal to first char, what do you think this will give us? We're storing a char variable inside of an integer value. Shouldn't it be possible, right? But it is possible. And if we run a print line statement here, we'll go ahead and put a string in here. We'll go ahead and give us a nice little layout here. We'll put the integer value 4 inside of quotes, put a space. We're going to use that concatenate plus sign, and we're going to put first char. Then we're going to put another plus sign inside quotes. We're going to put space is space. Keep in mind the spaces that we're putting here to make sure that this looks nice once it prints out into the console. We'll put another concatenation plus sign here. Then we're going to put char value. Now if we run this, notice what we get. We get the integer value for and is 38. So what that did is it actually took the Unicode value of the and symbol and stored that inside of the integer variable char value. Because integer variables cannot hold a char character, it's going to store that Unicode. It's going to store what it can basically, and it stores that Unicode amount or that Unicode integer value inside of char value. Now this could be pretty useful in some of your programs, and you'll notice that as you start to build some stuff. It might even help you solve some issues in the future. Let me show you something here to maybe give you an example. So if we put an A, all we do is change this A and start a first char, and we go ahead and run this program. Didn't change anything else. What we get is the integer value for A is 97. If we put B, we get the integer value for B is 98. If we put C in here, we get the integer value for C is 99. This is pretty much a basic program for you. You want to see what the Unicode value for a given character is. You could go ahead and do something like this, and all you have to do is just change that variable value, and you get the Unicode value back. That's a basic program. And as you noticed, for ABC, we had 97, 98, 99. Sometimes you might need to add character values in the future, and this is how you would do it, so just keep this in mind. And that's a basic introduction to how variables work in Java.